Hello and welcome to the video. Today I'm going to be going over some basic derivative rules. So let's get into it. So I'm actually splitting this up into two videos because there's just so many derivative rules. So just to recap, in the previous video we learned what a derivative is. We learned how to find a derivative, but it was kind of tedious. If you remember, the formula for the derivative of function f is given by f prime of x is the limit, so we need a limit as h goes to 0, of f of x plus h minus f of x over h. And we did a couple examples with computing limits, but it was kind of tedious. So the purpose of these derivative techniques, derivative rules and formulas is to kind of give us a shortcut, so we don't have to do that every time. And sometimes we can't just use our derivative definition. Sometimes these formulas can be very, very helpful, not only for saving us work, but they make it possible. So let's get into it. So we're just going to start with some more basic ones. So the derivative of a constant is always going to be 0. That's what c is, just some constant. So you can kind of picture, if this is our xy plane, and you have a function y equals c. Here, c is positive because it's above the x-axis, but it doesn't necessarily have to be. If you notice, this is just a horizontal line, and it has slope 0. So it's flat. And if you remember from the previous video, or if you didn't watch the previous video, if you just, if you know, the derivative tells us it's kind of like slope, right? It's the rate of change, really. So because the slope is always 0, because it's always flat, the rate of change is 0 for this horizontal line, it makes sense that the derivative of a constant function will just be 0. And the constant multiple rule. So if you're taking the derivative of, let's say, some function f, but that's multiplied by a constant, you can just take that constant out. So if you have, for example, the derivative of 2f of x, that's just 2 times the derivative of f of x, and you could also write that using f prime. Alright, so now we're going to really start getting to the meat and potatoes of taking derivatives. The power rule, it's one of the most important derivative rules. You use it probably all throughout Calc 3 even, because it's very important. It's telling you, if you have the derivative of something, of x to some power, it's telling you how to differentiate that. So it tells you how to differentiate powers of x. And it's x here, but I'd just like to know, if you have something like d over dy of f of y, that's saying something similar. That's just the derivative of f of y with respect to y. So you can change the variable, but the process, these formulas will still apply. I'd just like to note that. So this formula, or this rule, it tells you the derivative of x to the power of n. You bring down the power, and you subtract 1 from the exponent. So the derivative of x to the n is n times x to the n minus 1. Alright, so now we're going to get some practice with these derivative rules. So this is mainly for the power rule, but does incorporate, as you can see, some of the other rules, like that constant and that sum, or difference, I mean. So, for this first one, derivative of x squared, remember, we bring down the power, we bring down the exponent, right? So, and then we multiply it by x, and then we reduce the exponent by 1. So 2 times x to the 1, that is just 2x. And if you remember from our previous video, that is what we got when we did it from first principles using our limit definition. So it's a good thing that that tracks. Alright, for the second one, if you'll notice, this doesn't have the d over dx, this has a prime. That's the same thing. You'll see different notations. I went over that in the last video. Lagrange's versus Leibniz, but they're both the same thing. These are all derivatives. Okay, so first, if you notice, we kind of have two functions. We have 4x cubed, and we have 1. And we're subtracting 1 from 4x cubed. So if you remember, one of our pretty simple rules was that if we have a derivative of a difference, you can split that up. So this is going to be the same thing as the derivative of 4x cubed, so I'm going to use the prime, minus the derivative of 1. Well, if you remember, the derivative of a constant is just 0. So this is 0. Now, for this, notice we have a constant being multiplied on the outside. We can just pull that out from our constant multiple rule. So this is 4 times the derivative of x cubed. Derivative of x cubed, that's going to be, we bring down the power to the front, so 3 times x, and then we reduce the exponent by 1. So times x to the second power. So that's going to be 4 times 3 is 12, x squared. Should box my answers. Okay. Now the derivative of x to the 100. This seems kind of scary because it's a really big power, but it's really quite simple. It's the same thing as the previous one. Still applies. So you bring down the power to the front, so 100 times x, and you subtract 1 from the exponent, so the 99. Alright, that one's pretty easy. Alright, so we have 2 more problems with this. These ones are intentionally a bit more tricky. Okay, so first, we're taking the derivative of 5x squared root x. There's a few things that I want to note. First, we haven't really dealt with square roots yet for our power rule. But I just like to note, the square root of x is the same thing as x to the 1/2. So, first, another thing is we have this we have this constant being multiplied to x squared x. We can just pull that out. Whenever you have a constant, just a number being multiplied by something else, you can often just pull that out. It's often best to do that. So this is 5 times the derivative of x. I'm going to write square root x as x to the 1/2 power. So notice x, that's just x to the first power. When you're multiplying two things with the same base, you can just add the exponents. So we can just add these and combine this into one base. So this is 5 times the derivative of x, and then 1 plus 1/2, that's 3/2. So the derivative of x to the 3/2. Before, we've only really used whole numbers. We only really used things like 2, 3, 100, whatever. But you can also do it for rational powers and even irrational powers. So it's going to be 5 times. We bring down the power to the front. 5 times 3/2 times x to the 3/2 minus 1. We subtract 1 from the power. So that's 1/2. So I'm going to, since I had square roots originally, I'm going to bring that back. So this is 5 times 3, that's 15, over 2, square root of x. Okay. Now for this next one, I think we're going to need quite a bit of room, because this is intentionally the hardest one. So I'm just going to get rid of this. Okay. So, the derivative of cube root x minus 9x squared plus 5 over x. First, I think it's nice to just kind of do these individually. We know that if we, because of our sum and difference rules, we can just differentiate these individually, and then add or subtract them to get our final answer. So, first, let's just go in order. Derivative of cube root x. Cube root of x is the same thing as x to the 1/3. So this is the derivative of x to the 1/3. Now, if you remember, well, you should remember, you bring down the power, so 1/3 x, and then 1/3 minus 1, that's negative 2/3. So you could leave it like that, but I'm gonna, since it's a negative power, I'm gonna flip it. So this is 1/3 times 1 over x to the 2/3. Because if you remember, a to the negative b is the same thing as 1 over a to the b from algebra. Okay. So this is 1 over 3 x to the 2/3. That's how I'm going to write my answer. Okay. Now, let's do the derivative of negative, or let's just do, negative 9x squared. We'll just add them all at the end. Well, remember, we can always pull out that negative 9. So that's negative 9 times the derivative of x squared. And we already did this. We bring down the power, reduce the exponent by 1. That's negative 9 times 2x. That's negative 18x. Okay, now, last one. Derivative of 5 over x. Well, this is kind of confusing because this doesn't look like a power of x. When in doubt, just try and simplify. So pull out this constant that's being multiplied. So that's 5 times the derivative of 1 over x. Now, 1 over x, that's the same thing as x to the negative 1. So, this is where this comes into play. We can bring this down. So this is going to be negative 5, because we bring that negative 1 down. Or actually, let me just write it like this. 5 times negative 1 x, and then we bring the power down, the exponent down by 1, so negative 2. So that's negative 5, and then x to the negative 2, that's 1 over x squared. So this is negative 5 times 1 over x squared. That is negative 5 over x squared. Okay, so now we have all of our, probably shouldn't circle them. Now we have all of our individual derivatives. Now we just need to combine them to get to our final answer. So, let's make some room. Alright, so those are our derivatives we found. Now we just add them together. So, our final answer is going to be 1 over 3x to the 2/3 plus, or we're adding negative 18x, that's the same thing as subtracting 18x, minus, because we have a plus negative 5 over x squared, that's the same thing as minus 5 over x squared. Alright, that is our final answer. Alright, so the product rule tells you how to differentiate a product. So I just like to note, the derivative of f of x times g of x, the derivative of this product, that's not the same thing as f prime of x times g prime of x. That's not the same thing as just multiplying the function's derivatives. But what it is you take, here's what I like to think about it. So you take f of x times g of x, and you add them together, right? But for each of the different terms, there's two terms. For one of the terms, you do f prime of x, and the other one you do g prime of x. Alright, so for this first problem, we have the derivative of the square root of x minus 5 times 3x squared plus 2x plus 1. So, our product rule tells us how to differentiate products, and that's what we have right here. We could just FOIL this out, and then you use our power rule, but that's just overcomplicating it, really. So, what we do first is, this is like our f, and this is like our g. we do the derivative of f. So the derivative of f, that's going to be that constant. This is just going to go 0. Or how about I do this over here? F prime of x, that's going to be the derivative of square root x minus 5. That is, this constant is going to go to 0. We're differentiating it. This is the same thing as a 1/2 power. So we can bring that 1/2 down. And then x to the 1/2 minus 1, that's negative 1/2. So that's 1/2 x to negative 1/2. That's the same thing as 1 over. This is the same thing. This x to negative 1/2. That's 1 over square root x. So this is 1 over 2 square root x. Okay. So we have 1 over 2 square root x times our g, right? F prime times g. So 3x squared plus 2x plus 1. Oop. Okay. Now we're going to do we're going to do f times g prime. So now we need to find what g prime is. So g prime of x, that's going to be the derivative of 3x squared plus 2x plus 1. So for this 3x squared, remember we're just differentiating all of these terms separately and then adding them up. That's going to be 3 times the derivative of x squared. That's 3 times 2x. That's the same thing as 6x. Now this 2x, differentiating 2x, that we can pull out that 2, so that's 2 times the derivative of x. So this is just x to the first power. So you can bring that down. This is 2 times 1, right? If we bring that 1 down, x to the 0. X to the 0 is just 1, so we can just ignore that. So that's just 2. So this is 6x plus 2, and this constant term is just going to go to 0. So this is the derivative of g. So now we do f, so that's square root x minus 5 times the derivative of g, so 6x plus 2. Now we could expand all this out, but you really don't have to unless you're specifically asked to, or you know that your teacher would like you to. This is kind of a shortcut. Instead of having to expand everything out, we can just find the derivatives separately, and then we do f prime. I should probably change my color. We do f prime, and this is f. And we do g, this is g prime. So we do f prime g plus f g prime. If you keep saying that over and over again, the derivative of f times g is f prime g plus f g prime. That can kind of be a way to remember it. It's not too hard to remember, really. So yeah. Alright, so there's one more problem that we have regarding the product rule. So again, you could expand this out. We don't have any square roots this time, which is kind of nice. But it's really easier just to use the product rule because it's right there. It's a product, so it's kind of screaming at us. And also we can just leave it like that. Right. This is f. This is g. Once you find f prime and g prime, you just have to add together f prime g plus f g prime. And there's a lot less work with algebra, really. So notice we have our variable of differentiation is y, but that doesn't really change anything, as I said earlier. So we're going to go about it the same way, use the same rules, same formulas, but it's just going to be with y. So first, let's differentiate this first term. So d over dy of y cubed minus y plus 2. So for this first term, in this I don't know a word for it. So for y cubed, we bring down the 3 and we multiply by y squared because we're bringing down that power by 1. And then for minus y, we know that derivative of y is just 1, because this is the same thing as 1 times, see, this is the first power, 1 times y to the 0, that's just 1. And then we have minus y, so when we differentiate that, we're just going to get minus 1. And then this plus 2, this is just going to go to 0 when we differentiate it. Alright, so this is, let's call this f and this g. This is f prime. Now, we need to find g prime. So g prime is even simpler. G prime is derivative with respect to y of 3y plus 12. So, kind of a shortcut really is this is a linear function with slope 3, which means its derivative, which it gives the rate of change, is going to be 3. But you can go a step further. You can notice this 12 is going to go to 0 because it's a constant. And then the derivative of 3y, that's 3 times the derivative of y. And we already said the derivative of y is just 1. So this is just 3 times 1, which is 3. So that's 3. Alright, now we do f prime g plus f g prime. So f prime, we already said that was 3y squared minus 1. Alright, times our g, so 3y plus 12. Plus, now, f, which is y cubed minus y plus 2, times g prime, which is 3. So, there's a 3 over here. I find it easier, actually, if we bring this 3 out over here. So, 3 times y cubed minus y plus 2. Alright, that is our final answer. Alright, so we just learned how to differentiate a product. But what about kind of the opposite? What if we want to differentiate a quotient? So the quotient rule, it's kind of in the name, so it's pretty obvious. It tells you how to differentiate a quotient of two functions. So it tells you derivative of f over g. It's kind of similar to the product one. If you notice, we have f prime g and then f g prime. But here we're subtracting, so the order does matter actually. So f prime g, just remember, the derivative of the thing on top always goes first, and then you subtract the term with the derivative of the thing in the bottom. So f prime g minus f times g prime. So the derivative of f of x times g of x minus f of x times the derivative of g of x. You divide everything by g of x whole thing squared. So let's do an example problem with this. So f of x is 3x minus 5 over x squared plus 1. We're going to find the derivative. So let's label the top and bottom. Let's call the top a of x. So a of x is equal to 3x minus 5. And let's call the bottom b of x. B of x is x squared plus 1. So we know for our formula we're going to need a prime and b prime. We need to know the derivative of top and bottom. So let's just find those right now. So a prime of x, again, we can just use our shortcut. This is just a linear function with slope 3. So it's our instantaneous rate of change everywhere is just going to be 3. Our derivative is going to be 3. And the derivative of x squared plus 1, that's d over dx, or I don't know, I have any equals. So b prime of x, that's the derivative, x squared plus 1. This constant term just goes to 0. The derivative of x squared is 2 times x to the first power. That's just 2x. So now we have our derivatives. So now we can just plug this into our formula. So f prime of x is going to be a prime of x, b of x, minus a of x, b prime of x, over b of x squared. So a prime of x is 3 times b of x. that's going to be 3x squared plus 1 minus, all right, a of x is going to be 3x minus 5, and then b prime of x is going to be 2x. All divided by, we square the thing in the denominator. So b of x squared, that's x squared plus 1 squared. Whole thing squared. So yeah, you could expand this out. Actually, I'm going to do that just to simplify a little bit. I'm erasing to get some room. Alright. So, let's bring this over here. Or, actually, let's bring this over here. So, 3 times x squared plus 1, that's 3x squared plus 3 minus, let's expand this whole thing out. So, 3x minus 5 times 2x. Let's distribute that 2x to both of those. So that's 6, because 3 times 2, x squared. And then 5 times 2, x. Well, minus 5 times 2x, that's minus 10x. Okay. And then we're subtracting that whole thing. So this minus, this becomes minus that whole thing. So that's minus 6x squared. And that negative 10x becomes a positive 10x. So over here, we already accounted for that minus. So this is going to be minus 6x squared plus 10x over x squared plus 1. Let's just leave that as x squared plus 1 squared. So that is 3x squared minus 6x squared. That's minus 3x squared plus 10x. I'm going in order of power. Plus 10x plus 3 over x squared plus 1 squared. And that is our final answer. We could have left it like in this form, but it's kind of neater in my opinion, and it looks a little unfinished just leaving it like that. Alright, so now for some extra practice with the rules we've learned. We're given two functions, f and g. F of x is x squared minus 5, and g of x is cube root x plus 6x. So f plus g prime of x. This is the same thing as just the derivative of f of x plus g of x. So, that's going to be the derivative of x squared minus 5 plus g. So that'd be cube root x plus 6x. So this is just our like sum rule, because we can just differentiate all these terms separately and add them up. So 2x, that's the derivative of x squared, minus 5, this will just go away. The derivative of x to the 1/3 power, cube root x is x to the 1/3. So, remember we bring this down, and then we drop the power by 1. So, our derivative is going to become plus 1/3 x to the 1/3 minus 1 is negative 2/3. Again, I'm going to bring this to the denominator because it's a minus power. So this is 1/3 times 1 over x to the 2/3. And then we can just multiply like this. So that's 1 over 3 x to the 2/3. Okay. And then we have a plus 6x. Differentiating that will be, it'll just be 6, because the derivative of 6x, that's 6 times the derivative of x, and the derivative of x is just 1, so that's just 6. So yeah, that is our answer for the first one. Now, f over g prime of x. this one is more tricky. I'd say quotient rule of all these rules, it's not the hardest rule overall. I'd say the chain rule might be one of the harder rules. But I'd say it's pretty tedious. And for the rules in this video, I'd say it is probably the hardest. So f over g prime of x. We know we're going to need f prime of x, and we know we're going to need g prime of x for our formula. So let's just find that. F prime of x, we kind of already found that. That's we differentiated both of these terms separately. So x squared, we bring that 2 down, and then drop power by 1. So 2x to the 1, that's just 2x. That constant just goes away when you take derivative. Then g prime of x, again, cube root x is going to be 1/3, because we bring down that x to 1/3, times x to the negative 2/3, because we reduce the power by 1. So this is, we already kind of did the work. This is 1 over 3x to the 2/3. And then plus 6, because when we differentiate 6x, it gives us 6. We kind of already found it right there. Okay. Now, finding f over g of x, f over g prime of x, we're going to take f prime, so 2x times g, so cube root x plus 6x, minus f g prime. Wait, I'm just going to, no, I'll leave this, actually. Minus f is going to be x squared minus 5. And then g prime, 1 second, I'm gonna move this over, because we're running out of room. Alright, there we go, I'm just cleaning that up. So, and then this is f, and then our g prime, we already found that's 1 over 3x to the 2/3 plus 6. Alright, I'm writing kind of small. Over g of x, whole thing squared. So cube root of x plus 6x squared. I'm not going to simplify that, but I am actually going to write this. So write this more neat. So 2x times cube root of x plus 6x minus x squared minus 5 times 1 over 3x to the 2/3 plus 6 all over cube root of x plus 6x whole thing squared. Okay, so yeah, that it's not really going to get much nicer if we distribute it all out, so I'm just going to leave it like that. Alright, so I have one more bit of additional practice, just these 3 problems. So for this first one, we have h of x is 3f of x minus g of x. We want to find h prime of 4. So let's just write out the formula for h prime of x. That's the derivative of h of x. And and h of x is 3f of x minus g of x. So this is the derivative of 3f of x minus g of x. So that's going to be, if we differentiate these separately, derivative of 3f of x, we can pull out that 3. So that's 3 times the derivative of f of x, that's 3f prime of x. And the derivative of g of x, that's just g prime of x. I prefer writing it with the prime instead of with the d over dx. It's just neater, in my opinion. So this is the derivative of h of x. But we're not asked for the derivative of h of x. We're asked for the derivative of, we're asked for h prime of 4. We're asked for the derivative of h of x evaluated at 4. So if we just plug in 4 into our derivative, that's 3 times f prime of 4 minus g prime of 4. But how do we find that? How do we find those? Well, That's where this table comes in. So f prime of 4, we're given that's negative 2. So 3 times negative 2 minus, and then g prime of 4 is negative 1. So minus negative 1, that's a positive 1. So this becomes plus 1. So this is negative 6 plus 1, that's negative 5. So h prime of 4 is negative 5. All right. Now for the second part. F over g, oh, this is supposed to be prime. I apologize. F over g prime of 2. F over g prime of 2. Well, let's first just write out the general formula for f over g prime of x. Remember, that's f prime times g. So f prime of x times g of x minus f of x times g prime of x. Oh, whole thing divided by g of x squared. So now let's just plug in 2 into that. So f over g prime of 2. So that's f prime of 2 times g of 2 minus f of 2 g prime of 2 all over g of 2 squared. Okay, so we know f prime of 2, if we look, that is 1. So 1, and then g of 2 is 9, minus f of 2 is 3, and then g prime of 2 is also 3. And then all divided by g of 2. G of 2 is 9 squared. So this is 9, and this is 9. So this is 9 minus 9. That's 0 over 81. So the whole thing is just 0. So f over g prime of 2, the derivative of f over g evaluated at 2 is equal to 0. All right, so one last part. Let me write this. 0. So the derivative of f times g evaluated at 1. So let's first write out our derivative for f times g of x, or f of x times g of x. So this is going to be f prime of x g of x plus f of x g prime of x. You know, it kind of gets easier to say as you keep using it and saying it, or easier to remember, I should say. So, if we want to find f times g, derivative of f times g evaluated at 1, let's just plug that in. So this is f prime of 1 times g of 1 plus f of 1 g prime of 1. So we know f prime of 1 is 2, and then g of 1, f prime of 1 is 2, and then g of 1 is 3, plus f of 1 is 0, and then g prime of 1 is 4. So this is just 0, because 0 times 4. So that's 6. So this is 6. Should probably box those in different color. Alright, so that is everything. Alright, thank you for watching the video. In the next video, I'll be going over some other derivative rules, but they'll be a bit more specific. In this video, I was just kind of laying the foundation for taking derivatives with like the product rule, the sum rule, the quotient rule. But next time it'll be a bit more about specific kinds of functions. So anyways, thank you for watching. I hope that you enjoyed the video and have a great rest of your day.